Okay, so let's go over an issue that we obviously are facing. There's no cooldown. So there's a few ways we could handle this. I will offer it up to you guys to decide which way you guys want to go through. So there is the sort of hacky way that's a little bit jank, which would just be sort of putting a delay on the jump. So there's just a jump cooldown. So that means you can only jump every 3 seconds or something like that. So most games don't really function like this, but it's a good exercise in showing you how you can delay things happening, which tends to be pretty important in Unity. If you guys aren't feeling that and you really want to implement jumping like well, then what we would end up doing is doing an on-collision enter sort of deal, where we check to see when it's hitting the ground, and then when it starts hitting the ground again, that's when we turn on the ability to jump again. Any preferences on which one of those you guys want to do? On collision. Let's just get votes. So who wants to do time delay? And then who wants to do on collision? Okay, 2 for on collision. We'll do on collision then. And there's also another thing called raycasting you can do in this case, which might be even more efficient and consistent, but we haven't covered that at all yet, so we won't go into that right now. Cool, so let's put in on collision enter. Void on collision. And actually, I might do stay this time instead of enter. And first off, we have to provide a way to stop them from jumping. So up here, let's make a private bool and call it isJumping. And by default, it will be false. And then down here, we'll do isJumping equals true whenever we start jumping. And we'll only do this, we'll only start jumping if they've pressed down the jump button and they're not already jumping. So this is some notation we haven't introduced yet, but this not, or this exclamation point right here, this means not. You can literally just say it like that. So if they're not isJumping, and then we use these 2 and signs to say and, they press the button down. So some notation we haven't really gone over yet. It's unfortunate I wasn't able to go over with you guys today. Well, everyone else, I suppose. But that's what we're trying to say. So now, if we go back and test this one out, only press space, we'll only be able to jump once, because now isJumping is true, and it never gets set back to false. So that's fine. So now we need to use onCollision stay to try to enable it again. So the reason we're using onCollision stay in this case is I want to detect when someone is resting on the ground. And when they're resting on the ground, then that means that we can enable their jumping again. So first off, easiest way to do it is jumping equals true. Let's see if that works, right? Oh, you're right, false. Is jumping equals false. Right, so if they're staying on a collision, is jumping equals false. Let's see if that works. So I press boom.
See, that's what I'm going with.
Yeah, something like that. So you can see that sometimes it works as expected. Sometimes it's a little bit jank. But in this case, you know, it's working pretty well. It's not too bad. If I were to give some issues currently, I could jump on this and then I can keep jumping up a wall as much as I want because it's not detecting which angle I'm jumping at. It's just detecting whether or not I'm touching anything. So in this case, you can sort of just keep jumping up anything in the world. Like in this case, you can sort of jump up a tree. Oh, I don't have collision on that tree, so you can actually. So that's bare bones basic way to implement it. You can see that there's obviously some issues here related to how we're jumping. So sometimes it works out fine, sometimes it's really low, or sometimes it's really, really high for some reason. And like I said, that might be due to issues with how we're doing our jumping. Okay, so that is actually pretty good. That does the job relatively well. You still have the issue though where it's detecting when you're pressing up against something, where it really should only be detecting things where you're on the ground. I'm going to write this out and explain it afterwards. So you're going to do, well, this is going to be awkward actually, but here we go. Oh man, yeah, this is you guys definitely wanted on this one. This one is slightly more complicated. So the way we're gonna have to do this is, let me see if it's contact normal dot. Is there a dot? Nope. So we have to do vector 3. Oh man. So there's gonna need to be a lot of explaining after this one, to say the least. Or we could just check it more easily, actually. Yeah, that's a tough one. Yeah, I'll do it that way. So if contact dot normal dot y is greater than 0.8. Okay. And this might be wrong right now. I might have it inverted in my head. But we will see. Actually,
0.6.
it might be less than. Actually, I'm going to try that for now. It might be inverted. Okay, let's zoom in on this one. It's a little bit easier to read. Let's go through an explanation of how this works. Cool. So, collision gets sent in whenever we do on collision stay, on collision enter, anything like that. Actually, let me confirm this works first. Because this is totally off the cuff, seeing if it will work out well. No, yeah. Let me try if we do greater than 0.8. Okay, yeah, so the jumping's still jank, but it works. Okay, cool. So this is the correct one, more or less. And I can showcase later on how it's working with the other one. So what's happening is we have collision, which gets passed in. A collision represents all things that are currently colliding with this object and colliding. So inside of it, there is collision.contacts. So all current contact points. So what we're going to type in is say, we're going to say this nice syntax for each. So for each whole.contacts, and we're going to give them the name contact. We're going to give them the name contact, because that was a contact point. So for each contact point in whole.contacts, we want to check if the normal of that contact is blah, blah, blah. So the normal of a contact means that if you have an object like this, and say that your sphere contacts it right here, in this case, the normal of the contact is going to be that right there. So it's going to be the direction pointing directly out of the surface that you're on. If it was down here, then the normal would be pointing that way instead. So what we're doing in this case is we're checking that normal, and we're making sure that the y value of it is at least 0.8. Now this is a pretty hacky way to do it. If I were to do it another way, I'd probably use the dot product for anyone who's interested or anyone who's familiar with vector algebra. But since some of you guys might not be, I'll hold off on it. So what we're going to do is we're going to say the y has to be greater than 0.8. And the reason we can do this with relative confidence is that every single normal vector has a length of 1. Only 1, for sure, guaranteed. So that means that the length is only 1, and if this is 0.8, the other ones probably aren't that high, is sort of the idea. 0.8 might even be a bit low. I might crank it up to 0.9 or something like that to guarantee. It's pretty guaranteed that most of it is going up. Because I want it to be if the player is like on a hill and they're like right here and it's like this, I still want them to be able to jump in this case. Like that's pretty okay for me. But, oh, sorry, I'll draw it up here. But if they're like here and the normal is like that where it's like almost up, then they still should probably be able to jump. So if that's the case, then is jumping equals false, let them jump again. And we're going to do that for every single contact because, say for instance, we have this right here. You might have something like this, and your character is like sitting right here. So you'd have 2 normals contacting it. Or maybe you have a wall, and you have your character right here. So they would have a normal right here and a normal right there. So you want to make sure you check all those contacts. Guarantee that at least one of them is pointing up. If at least one of them is pointing up, we're probably good to go. I'm going to change this to 0.9. Ideally, you'd probably expose that 0.9 to the editor so that your designers can change it. But let's go ahead and check this. So what we need to do is jump into this wall. And it's like you can see that I'm trying to jump, but it doesn't let me jump infinitely, that's for sure. Not like I was able to before. It lets me jump a little bit, but yeah, it's not doing what it used to before, that's for sure. So it does really guarantee that you're on the ground first. And that's how I would probably implement it using what we've already learned. If I was doing something else, I might use raycasts instead, which involves just like looking directly below you and then checking if you're standing on top of something. But I think this is a pretty good way to do it. And it's pretty consistent too. Okay, probably some questions about that. Any questions about what we did here or why we did it? It's a little bit, it's diving into like deeper sides of Unity that we haven't really touched yet, like normals and like stuff that's like getting more into like the graphics-y and physics side of things that we haven't touched really much at all yet. So don't be worried if this was like intense or anything. I was going to show them the really basic, just wait for 3 seconds, then jump during the actual workshop. That is much simpler, and it's very easy to do. If you guys want to know how to do that, just because I think it's useful, the way you can do this is if you have something like a function right here, so say you have void and call it jump cooldown, something like that, right? And just say is jumping equals false. What you would do instead is you would just go down below here, and you just call it invoke jump cooldown, and then just give it a number of seconds to wait before doing that. And then all of this code could be avoided, and I could comment this out, and we could see that in action. And press space, jump a little bit, keep pressing space after 3 seconds, or not. I'll just go forever. That works too. Let's see, why would that be happening? Oh, I know why that happened actually. That's pretty funny. So if I press space, and if I press space one more time. So pretty much if I keep mashing space, those jump cooldowns are going to keep building up together, I think. Or I'm just doing something wrong, which could be true as well.
Maybe are you sure it's 3 seconds or is 3 frames?
Yeah, it should be 3 seconds if I remember correctly. Float time in time seconds. Yeah, I can confirm with mine to make sure that's what I did. Pretty sure I did pretty much that. Yeah, that should be what's happening. But I think it gives you an idea of how it works. We could also just debug.log off cooldown. something like that, and see, and then we can sort of quickly check to see when it's being logged based on down here. It's going to be a little bit tough, actually, because of all of these. Okay, so there's so many things being shot out from this right now that's going to freak out. I'm going to log a warning instead, just so we can actually see it. Don't do this in practice. Not usually a good idea to log warnings when it's not really a warning, but that's okay. So I'm going to turn those off, and then whenever I press space, oh yeah, so there's definitely an issue here since off cooldown is being called multiple times all the time. Yep, figured it out. Cool. We're going to put this inside of the jump handler, so it only happens when we're jumping. That will definitely do the job. Cool. So that's a good way to show how you can use the debugger to find your problems. So let's test it out now. Space. Space. So works about how you would expect it. And the reason it wasn't happening at first is because it took 3 seconds for the initial one to kick in. And after that, all the other ones happened. So yeah, that covers jumping. I gave you guys the complex version of it because you asked for it. Don't get freaked out. I wouldn't usually throw that at you guys at this level, but I feel like it's sort of cool sometimes to see what you can start doing with Unity past the basic stuff that usually is covered in tutorials. There's a lot of really cool, nice engineering stuff that you can start doing actually when you start building out those things and actually organizing all these systems together.